Here's another composition of functions question, but this time we don't have numbers to work with, so it might seem a little bit trickier, but let's try it. The other difference between this one and the previous example is that the notation is different. So we have f o g of x, which isn't fog. This O in the middle is actually not the letter O, it's a little operator, and it's a composition operator. And what it means is that we do F after G. So we're going to do G of X first, and take our answer for G of X and put it into F. Okay, so we begin with G of X. Okay, we always begin on the second one, F after G. Okay, so we're going to do G of X first of all. So G of X is 5 minus X. And we don't have to work anything out. We don't have to put a number in here like we did the last time. What we're going to do is we're just going to take this expression, 5 minus X, and put it into F. Okay, so let's go back now to F. So F of X is 4x minus 2. But what we're going to do is where we had the x, we're going to put in our g of x, which is 5 minus x. So this is now going to become 4, and then instead of x, we're going to replace it with 5 minus x. And then we still have to have that minus 2 here. Okay, we don't get rid of the minus 2. So we're replacing the x with this 5 minus x here. Okay, so we wrote down g of x first, and then whatever answer we got for g of x, we put that into f instead of the x in f. And from here on, it's kind of traditional algebra. So we distribute the 4, so 4 5s are 20. 4 times negative x is minus 4x minus 2. And then just add like terms, we have 20 and 9 minus 2. Those are just regular numbers. So 20 minus 2 is 18 minus 4x. And that is, I should have changed it here actually, f o g of x. So f o g of x is equal to 18 minus 4x. Okay? And what this means is that no matter what number you start with, let's say you started with 1. Let's say your initial x was 1. And you put 1 in here into g of x. So if you put 1 into g of x, you would have g of 1 is equal to 5 minus 1, which is equal to 4. And then you take that answer and you put it into f. Okay, so you take that answer and you put it into f. Now f is 4x minus 2, so 4 times 4 minus 2. So 4 4s are 16. 16 minus 2 is 14. Okay. Now if we start with 1 down here, instead in this one, f o g of 1, we get 18 minus 4 times 1 is 18 minus 4, which is also 14. So in other words, what we have done in our work by developing this composition is given us a shortcut for finding the answer in one step rather than the 2 steps we used up here. Okay, so that's what it does. It's a shortcut for helping to work things out. Okay, the next thing we have to do, part B, is GOF of x. Okay, so let's do that one now. So part B, GOF of x. So this time we'll start with f. So f of x is 4x minus 2. Now, g of x, if I can scroll on my screen, and g of x is 5 minus x. We can see it here. So g of x is 5 minus x. So g after f of x, what we're going to do is going to be 5 minus, and then we're going to replace this x with 4x minus 2. Okay? So it's going to be 5 minus 4x minus 2. And since the x followed a negative sign, it's really, really important to put in parentheses. Okay? You should always use parentheses, but following a negative sign, it's an absolute must. Okay, so now we have 5, and then we distribute the minus sign, or change the sign of everything that follows, whatever way you want to think about dealing with minus signs. So this is going to become minus 4x, and the minus 2 will become plus 2, because you're distributing the minus and distributing minus 1. Again, add the like terms. 5 and 2 is 7 minus 4x. So g after f of x is 7 minus 4x. Okay, and those are our two answers. Can't squeeze them both in their entirety into the screen, but that's everything you've got there. Okay, again, thank you for watching.